Hi, this is Robert, and I wanted to begin this video first with a correction on a stupid mistake I made on the last video. I said I didn't think I was sick, even though I had a hoarse throat. I think I may have been sick because I really did a dumb error. Caught it this week, but not before ordering all new resistors. For the project, I ordered the Panasonic metal film 3-watt resistors from Mouser. They're the ERX series, and they're coming pretty blue there. And I measured those and just, did my usual thing. Turned it on, shorted my leads together, hit the rel button, got my zero reading, and all of a sudden I went, oh. Yep, I had forgotten to zero out my leads when testing the Silicone resistors, and sure enough, this is their 1 ohm 5%. You can see it's well within 5%. That's close to 1%. Here are the 0.47. It's reading 0.47 exactly. And this is another 0.47. It's reading 0.46. So you can see these are all well within spec. I could have used them, but apparently I had a small attack of brain death. I hope I'm over it now. My apologies if anyone was misled by that. These Icon metal-oxide resistors look like a good product, well worth using. Unfortunately, since I'd spent all the money on the metal film resistors, I went ahead with them. Also, since I found that I had an F5 parts kit that used the same parts exactly, so I went ahead and kept those. So I have the metal film, Panasonic metal film 0.47 in there, and the Panasonic metal film 0.56, and then this is a Vishay Dale 100 ohm 1% metal film, big old thing. But that pretty much does it for the big resistors. I already went ahead and put in the pots because I couldn't find an extensive set of zeroing instructions for it. I'm going to have to wing that, or at least sit down with the schematic and figure out what's going to give me the lowest amount of voltage present on the MOSFET gates. Set it up that way. So I don't have much left to put in on this. I have some big capacitors, and then finally the transformer. The capacitors I'm saving till next to last because they're so darn tall. They're going to block everything else once they're in. Oh yeah, I don't have the input pairs in yet. But anyway, you want to save the transformer for last because it's a big heavy thing and it's at one end of the board. So the board's going to be very lopsided weight-wise. So I've been doing other things. We'll swing over here. I've been working on power boards, and from what I've seen, I may not be able to cram 2 independent power boards into one of the chassis they recommend for the, for the F6. That's the Deluxe 4U, I believe. Anyway, I've got, I kind of went against the seams. I probably should have waited to put, before I put these in, and put the transistors in first, because I'm going to have a tight fit getting the transistors in, and it may even be a tight fit, yep, with this. So I'm going to have to mount them onto the heat sinks good and tight, and then mount them, mount them on the boards. So I got a little ahead of myself. These boards always look so cool once you get the capacitors in. Okay, first bias, or the offset adjust pot is on the top here, and I'm setting it for 0 ohms from the wiper to ground, which should give us the least voltage across the pot. And right now I'm measuring, measures of course around this is 2.29K, and see, yeah, I'm going the right direction, so I'm turning the pot down. So basically what we're doing is the Zener's going to be making full voltage, but we're only looking at it down at this end of the potentiometer here. So what I'm trying to do is ensure that when I power the amplifier up, the bias is at close to 0. Don't want to have any surprises. Okay, there we go. So, and basically I've gone from the top of R9 here, the 10K, to the anode of the Zener diode here. So basically here to here. Okay, on the other side it's a little different. So we're looking at R10, which is, see, I'm looking at the back here, I can see the wiper goes to this end of R10, and you can do a quick measure check by touching where the center pin or the wiper of the pot is exposed there. You have a duplicate land there. And then the other end is going to be at the negative rail, so you can either clip on here, get this is 2.38K, or I think you can get it here, yeah, 2.38K. So I'm clipping onto basically at the bottom of R2 the 0.47K resistor, and then at R10 the 10K, and that gives me my reading from the, the wiper of the potentiometer to the negative rail. And then I just turn it, yeah, I'm going the right direction. Resistance is decreasing on the meter. Down, 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 down. We're under a K now. And that's it. Okay, that's for that one. And this is which? The left board? I don't know which is which. I guess you choose. I don't know where they label the boards, but let's see. So this is the other style board. Let's see if it's any different. So first P1, we're going to go from the anode of Z1 to, let's see, look, I'm going to cheat and look at the back. The top of R9, the 10K. There's our 2.4 K ohms, and it's going down. See, going down, down, down. Okay. Okay, that was easy. I was afraid the two boards would be radically different. So again, center wiper. I can see it going under. So now I'm looking at P2, and the center's going to, well, let's just ohm it out. Looks like it's going here. Yeah, that looks pretty high. So we're going to be going from, still looking for where that center wiper went. There it is. So it goes from here. This must be R10 right here. I can just barely get a hold of that. There we go. So I'm measuring again from one end of the resistor to the from the one end of the resistor to the wiper. Then I'll want to also clip onto the rail for, there we go, yeah. So now I'm at the bottom end of the 0.47, and we're going the right way. Turn that down. Wrestle that out, and this board's done. Again, we're going from here to there. We're on P1, and we're at the top of R9. Now we go to the anode of Z1, and we get our, we're seeing half of the 5K potentiometer track. So that's done. And really, I just had to stop and think at it for a minute, figure out, well, what do we want? We want to have this wiper at the lowest voltage possible relative to the Zener, so that's why I'm basically pulling it towards ground, or in this case, the case of Q2 and P2, it's bias pot, taking it down near the rail. So that's why we're clipping on here to the bottom of 0.47 is this end of the pot, and then the wiper is on this side of the 10K. No, where was I? That side? Nope, it's here, I think. Nope, totally lost it. Let's see. Wiper goes to, not there, not there, there's the wiper. Okay, that's the wiper. And then the, we can also, we could go here to R2, which I thought where I was, or we could also go to the Oh yeah, this is the one I already adjusted. Okay. I knew I adjusted one before, so this guy's done. So that is pretty much it in how to zero these potentiometers out. You want to do that, of course, before we power the amplifier up and have the output devices slammed on full. We'd much rather ease up our bias on these so we don't have any nasty surprises. So this will take some explanation. What's going on here? This is a piece, obviously, of aluminum foil, and I'm using it as a poor man's anti-static mat. If we look over here in the corner, God, I need to figure out how to maneuver this contraption. There. I have my anti-static clamp clamped to the foil. Also under the foil are some leads going down, and they are grounded to my power cord for the soldering iron, where it goes into the extension cord. So essentially, I am directly grounded. This is directly grounded. There should be minimal chance to generate a static charge here. I have to say this is not the safest routine. Usually an anti-stat mat there's a fair amount of resistance isolating you from earth ground for safety reasons. In case you should contact the higher voltage, you don't want to make yourself the most available ground circuit. So they'll often put like a 1 mega ohm resistor or something in line. So at this point, what I'm doing, I'll tell you what I'm doing. I am putting the Schottky rectifiers on their heat sinks, which we can then solder onto the power supply board here. This is the DIY audio power supply board. I went ahead and got the caps and jumpers in, so the rectifier board is still one with the main board. These are the actual output of the rectifiers, just going right into the filter banks. I've also put in the ground jumpers connecting the boards together, and there's extensive jumpers on the grounds in the back to connect them. What do I need to talk about next? These heat sinks they should be big enough. I wish I could get bigger ones, but it seems like the taller ones tend to have too large a hole to fit in this footprint. These have two little pegs on the bottom, which mount in these holes on the power supply board. Didn't punch that one out. So let's talk mounting hardware. You can go with regular zinc plated steel in about a 440 standard machine screw size, and you'll be good. I recommend having the coolest ones are of course the Allen heads. If you can get them, they look the best, but I mean, you can use a standard Phillips head screw. I recommend having a lock washer and a flat washer. One, it helps distribute the load on the pressure evenly on the top of the transistor. But two, it also adds a little bit more thermal mass. I go with stainless steel because it's slightly less magnetic than regular steel. And if you live in a humid climate, you don't have to worry about opening your unit up 5 years later and finding your screws all rusted. So these are the Schottky rectifiers. I got a tube of 20. And these came from Mouser. It's part number MBR 20200CTG. These are the 220 size. I Have not had much luck finding the larger, I think it's TO247 size ones. But anyway, this is a standard TO220 format for a power transistor, or an IC regulator, or in this case, it's a dual Schottky rectifier. There are actually two little diodes in here. That's why they have 3 pins. Some power rectifiers, like the hex freds, will only have the 2 outer pins. This stuff is vital, but it's often over-applied, overused. This is, I always refer to it as Heatsink Compound, but it says here they call it Silicone Heat Transfer Compound, which is a nice description for it. I got these on eBay. I usually end up having to buy a fairly large quantity of it, like a lifetime supply in one purchase. And I felt really lucky to find these little, they're almost like sample packets of the compound, which is good because since you use it so sparingly, you don't have to use a lot, and it lasts a long time. So anyway, that's almost too much that I've just put on here. So I'm going to wipe some off. You want as thin a layer as you can. It's mainly there to fill in any gaps between the back of the transistor and the heatsink. Contrary to popular belief, it does not promote conductivity. It just fills in the gaps. If you put too much in there, it'll actually start insulating. But anyway, so I've then mounted the hardware on, and this washer is just, it's borderline too big, but it'll work okay. This is metric hardware. I believe it's size M3, but these heat sinks are tapped for, they're threaded to mount a screw in, and I just screw it down just finger tight, just tight with the short end of the Allen wrench here rather than the long end. You don't want to do that because you could probably strip it out. Oh yeah, so the next step, which I skipped the part, I got ahead of myself, is bending these out and then down, because they don't quite line up. If you look, the TO220 holes are way in front of the mounting holes, so it's not an easy line up thing. So we'll just set that there, and that goes in there, and we just want, I'm in one but not the other. Oh, I'm too far back. Good. Okay, so that's how it's going to look. So, not my best one, sadly. So, we'll do another one just to give you the idea. But these were easy to find. Ace Hardware has an aisle where you can find various bits of hardware and buy them in individual pieces, which is just great. Now, they don't have super small stuff. They don't have that many electronic specialty things, like you won't find your ground lugs there. But they do have smaller sizes of regular hardware, and they of course go up to the bigger stuff, like 832 or 1024 size machine screws, that kind of stuff. So in this case, you notice I put my bend in beforehand, which is what I forgot to do last time. So then we use the heat shrink compound again. Heat sink, not heat shrink. Okay. That's way too much once again. You just need a little thin layer and a finger. There. I get very nostalgic about this stuff because my main memory of working as a repair tech at a stereo shop for a few months was coming home wearing this stuff. It can be messy. So again, put that on, and then we'll see if it fits. Hopefully you can see all this. There we go. But yeah, we want it in straight, and I push down on the heatsink, which puts a bend on the transistors how it should be. We'll double check this one again. This was the problem child. Yeah, see if I push it down, I get a little more bend on it. But now it doesn't want to come out. There we go. Okay. I'm filming with quite a contraption here. I have my tripod, which you heard fall off the table last time. And I've got my Chinese GoPro knockoff cantilevered out from it on every adapter piece of hardware I could just to get some length on it. All that mess is duct taped and band tied to the tripod mount. So it's a clumsy thing, but it seems to be working for now. Heatsink compound, again, just a little bit, and then spread it out. Be able more or less to just see through it. Make sure that's in straight. And check the fit. Goes. Press it down, get that bend right. We're good. One more and we can start soldering. Now you probably noticed I have this yellow tape over the circuit board. This is Kapton tape. And it's got this kind of copper amber color to it, but it's a non-conductive plastic, and it's just generally used for its insulating properties. I was just concerned that should one of these guys get too hot, it might burn through the soldering mask on the board, so I've put the Kapton in place there to keep it from doing so, give it a little more insulation. So if you can see, I put a little bend in it there. Good God. See? When you put it on, you can hear that it's a very thin layer. goes in. This is actually a standard SAE size. It's a 5/64, but it fits that. It must correspond to the European, some European value. So it works quite well on these. All right, so that looks good. Let's see. Now the other thing that concerns me, as you notice, there's no insulator on these, so the heat sinks will be hot at whatever voltage they're on. So the other important thing here is that we don't want to have any close physical contact between them. So, which means when you solder them in, you want to push the heat sink forward or away from its brethren. Now the other tough thing is figuring out how to hold that up, because before I had the board separated. Oop, there went the solder. So you notice, I don't know if you can see, but the pins are forward. So what I'm going to do here is just there. That's hard on the fingers. So we'll do that there. I'm using, this is my common 6040 lead solder. I want to use it for the to hold the heat sinks in. And then I can go back and use the fancy solder on the rectifier terminals themselves. Even though they have a huge heat sink on the back of them, they are still heat sensitive. So you don't want to keep the soldering iron on them too long. Ideally no more than 5 seconds per pin. This is my new solder tip. I was able to find some new ones for my aging Weller iron here. And sadly, the availability of the tips is getting, they're starting to get a bit scarce. I could not find a 800-degree screwdriver tip. So it looks like about all we can get these days are conicals, which is what this is. This is an 800-degree conical. So again, I want to push that forward if I can. This is a structural solder basically. We're soldering the heat sink in on these non-connected pins, which are just there to hold it in place. I almost whipped the so make sure that's good. I'm going to see if I can push this forward a bit more. Okay. So one of these days I'm actually going to save up the money and get a decent soldering grounded anti-static mat for this table. 2 down, 6 to go. So if we get those in, then there we go. And I want to push the heat sink down and away if possible. Yeah, like that. I want to see that the pins here hopefully near the front of the holes, and hold them in basically that position while I solder them in. Too much solder on that one. Not that it's critical here. Make sure that's a little crooked, so I'm gonna still looks in a little. It's going to fight me. There, now it's in line with the others. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. The smoke keeps coming up in my face. Now, conical tip isn't my favorite. I'll take an 800 degree conical over a plain 700 degree tip any day. Again, these get pushed forward. But I recommend that you have some kind of, at least a anti-static wristband when you solder in your MOSFET. That, or wait for a rainy day. See, that one's, you look, that one's tilted in again, so on. That's going to need some maneuvering. You want to do it now while you can get at it. As it is, I've kind of painted myself into a corner here with insisting it be one board and then having mounted the filter caps too soon. Now we're not, still leaning back a little bit. Disappointing. So, it may be that the bend in the transistor is resisting us, so I'm going to put a little more force on bending it forward a bit. And there, it's lined up with the others now. Oh yeah, get the rectifier. But I have a sponge over here I'm cleaning the iron on. They have new dry systems that appear to work fairly well, but sponges are cheap. I've heard they're hard on the tips though, and that there's a miniature steam explosion when the tip hits the wet sponge. I tend to use just a damp sponge. Just damp enough so that the tip doesn't melt the sponge rubber. So it looks like these center pins could maybe use a touch-up from the top here. It's a big land. So you want to be very careful doing this. Again, you want the solder to flow. That one's good without hurting anything. That's another big land, isn't it? Go in there, just add a bit of solder. You have to be real careful because you don't want to create what's called a solder bridge. Because the solder, if there's enough flux between the two pins, the solder can just go blip and make a union, a bridge between the two. So now let's see how these will go. Yeah. See, if you get it just right, you get a good 1/16 of an inch or so between them. And since we're dealing with 23-volt supplies, there's little chance that an arc will jump from one to the other, so I'm not terribly concerned. And we can also bend these forward to add to it. There, make sure those pins are out towards the outer edge of the mounting holes there. You could probably cheat it and tilt them. The heat sink's about 5 degrees out if you're concerned, but I'm not that worried about it. Okay, this one's good. This one has inadequate solder. You can see there's a little depressed ring around it, so we'll do that. Okay, see how that looks on the other side. Nice. There you can see a clean, nice clean 1/16 of an inch division. Some other tricks you can do. Is what I guess I'd call staggered soldering. I'll show you that, how to do that next. Just as insurance if you're concerned that you might damage your parts with too much heat. Ooh, I just gripped solder on the board. that one's leaning back a little bit, so I'm gonna see if I can pull it forward a tad. See how that looks. Much better. It's actually is leaning out a little, so overdid it. You don't have to be OCD to do this, but it helps. So what I'm going to do is go on to the next two and get them, the heatsink, mechanically soldered in, and then go back and do the transistors. Never drop the iron in your lap. Not a good thing. That looks, oh, terrible, leaning right back into, almost touching its neighbor behind it. So we'll see. Much better. Okay, and the last one. Push these forward and make sure there's space there. And after watching me do this, you may decide to separate the boards. It is easier if you can just rest the parts on something underneath. Yeah. That should be okay. Okay, now I mentioned something called staggered soldering. I don't know what the actual term would be, but what we're going to do is just go through, we're going to minimize the heat impact on each individual transistor. So we'll I rushed that one. 1, 2, 3. But I'm going to do pin 1 of each transistor, pardon me, rectifier. And in the time I've done these, this guy's had a chance to cool down. So we can go now to pin 2. And so on. So you're just creating a bit of a cool down period between soldering pins. Connections. In most of the cases, the solder has flowed through and made a pretty nice looking joint on the top. Doesn't look like there are many connections on the top with these. I just see maybe 1 or 2 spots that could use a little Band-Aid touch up. So these are all in. Next thing, Diagonal cutters, finger on top. You don't want to have those little leads flying everywhere into your other projects that may be in progress. That's done, and if you want, you can also check your joints. Just all I'm doing is scraping away the flux between the joints. Make sure there's no risk of a solder bridge between these pins. And then I'll come back and clean that with alcohol. So this board is almost 95% done.